Hello, everybody. In this chapter, we will define statistics and we will know some important definitions in statistics as well. Let's get started with the definition of statistics. Statistics is the art and the science of designing studies, includes collecting, classifying, summarizing, and organizing data. After we collecting the data, we analyzing the data produced by these studies, and then translating the data into knowledge or information that we can understand or let us understanding what is going on around us. As you can see here in these photos, we have a table filled with a lot of numbers. Of course, our brain cannot process this table by just looking at it. So we have to use some statistical tools so we can translate this data or analyzing this data into graphs or numbers. These numbers we can understand the meaning behind them, so we can understand the what is going on behind these numbers. Of course, we collect the data in statistics. So any information we can gather with experiments or surveys, we call them data. For example, if we have an experiment about on low carbohydrate diet, so in this experiment we can measure the subjects. Of course, the subjects will be people before and after that diet. If we have another example, a survey on effectiveness of a TV ad, for example, we can measure the percentage of people who went to Starbucks since the ad aired. Of course, in this survey, we will know if the percentage goes up or goes down, so we know the effectiveness of that TV ad in this case. Three main components in statistics, so we can answer any statistical question: design, description, and inference. The design means planning how to obtain data, how to conduct the experiment, or how to select people for the survey to ensure trustworthy results. Descriptions means summarizing the data obtained and present it in a useful format, maybe numbers or graphs, as we will learn in this class. Inference, which means making decisions or predictions based on the data. Also in this class, we will learn some basics about probabilities. The probability is a framework for qualifying how likely various possible outcomes are. For example, if Brown were actually going to lose the election, that is, if he were supported by less than half of all voters, what is the chance that an exit poll of 3,889 voters would show support by 53.1% of the voters? So, of course, when we come to the probability chapter, we will know how we quantify or calculate the probabilities for such events in this case. Another two important definitions are about the subjects and the variable. Subjects is an entity that we measure in the study. So maybe it's an individuals, people, I mean, maybe schools, maybe countries, maybe county, maybe states, maybe bacteria, maybe prices of a specific product or days. So this is the subject in statistics in general. The variable is a characteristic or property of the entity, experimental or observational unit in the population. For example, if we are interested in the height of the students in our class, so in this case, our identity are the students. Our variable is the height of the student. So it's just, as you can see, one property or one characteristic of our identity, the height of the students in this example. As you can see here in this title, we observe samples but are interested in populations. So what is the sample in statistics? What is the population in statistics? Population, of course, in language means the number of people in a specific area, right? But in statistics, it's not like that. The population is the total set of subjects in which we are interested, okay? The sample is just a subset of the population for whom we have data. As you can see here in this Venn diagram, in the green circle represents the population, okay? And the sample is just a subset from that population. Okay? Of course, we will learn in this class how we can select samples from the population when we come to the sampling methods. For example, the purpose was to predict the outcomes of the 2010 gubernatorial election in California. An exit poll sampled 3,889 of the 9.5 million people who voted. Define the sample and the population for this exit poll. Of course, 9.5 million people represented the population, and the sample was the 8,889 voters who were interviewed in that exit poll. Another two definitions for descriptive statistics and inferential statistics. Actually, statistics has two branches, descriptive and inferential. So descriptive statistics refers to methods for summarizing the collecting data. Summarizing consists, of course, of graphs and the numbers such as averages and the percentages. Okay. Descriptive statistics, we use tables, graphs, and the numerical summaries tools to represent the statistical results. The inferential statistics refers to methods of making decisions or predictions about a population based on data obtained from a sample of that population. And another word, the inferential statistic is to draw some conclusions about the population using samples with some degree of uncertainty or a measure of reliability. Statistical inference is an estimate, prediction, or some other generalization about a population based on the sample. Okay, so we have here an example for descriptive statistics. This is a graph. We call it bar chart, okay, or sometimes the bar graph. As you can see here on the x-axis, you have the education level. We have no high school diploma, high school or equivalent, some college less than a 4-year degree, and the bachelor's degree or higher. On the x-axis, we have the percentage of US adults. So these bars, of course, represent here the number, the percentage of each category we have here about the education attainment levels. As you can see here, it's obvious that bachelor's degree or higher is the higher category we have here. It's about 30%. Some college less than a 4 years degree, it's about, can say, 29%. High school or equivalent, it's about 28%. And no school, high school diploma, it's about, can say, 13%. So as you can see from this graph, we summarized 78,000 households in the 2013 current population survey about the educational attainment levels. So look, all these households, okay, we summarize them in just this simple graph, as you can see here, okay. So this is an example of descriptive statistics. Of course, I will show you how to do something like that, to construct a bar chart or pie chart or any other charts by Excel in the upcoming chapters. Okay. Example for inferential statistics. Suppose we would like to know what people think about controls over the sales of handguns. We can study results from a percentage pool of 834 Florida residents. In that pool, 54% of the sample to subjects said they favored controls over the sales of handguns. We are 95% confident that the percentage of all adult Floridians favoring control over sales of handguns falls between 50.6% and 57.4%. So as you can see here, this is an example of inferential statistics. Okay, the first point here, this percentage there, we call it a point estimate. Okay, the second point here, we are 95% confident that the percentage of all adult Floridians favoring control over sales, and these two percentage between 15.6% and 57.4%, we call it confidence interval. Confidence interval. And we will learn how to find these two method of estimation when we come to the estimation chapter. Okay, so this is an example for inferential statistics. Okay, so as you can see here also from a sample 834, this is just a sample from the entire Floridian residents. Okay, from this sample we conclude this percentage. So here we study the samples and we generalized this percentage to the entire population. So this is inferential statistics. Okay, two important definitions: the parameters and statistic. A parameter is any numerical summary of a population, which means when you calculate, for example, the average or the percentage from the entire population, so we call this percentage a parameter. If you calculate this percentage from a sample, we call it a statistic. Okay, for example, as you can see here, percentage of the population of all Florida residents favoring handgun control, this is a parameter. This percentage is a parameter. Okay, but the 54% of the sample to subject said they favored the controls over the sales of handguns. This is a statistic. Why statistic? Because we calculate it from the sample, not from the entire population. Okay, so this is the difference between parameter and a statistic. So the process of a statistical study, as you can see here, we start with identify the cause or the statistical questions, and then we define our population, the frame of our population. Okay, if they are people or animals or bacteria or whatever. Okay, and then we draw a sample from the population, and from the sample, of course, we study the sample by summarizing the data. Summarizing the data maybe in graphs, maybe in numbers. Okay, and then we calculate the sample statistics from the sample. In our course here, we will learn how to calculate the mean and the proportion or the percentage. Okay, and then we use the inferential statistics. Okay, so we can generalize the findings from the sample and to the population. Okay, so we make inferences about the population in this case, and then we draw a conclusion about the population parameter. So as I said to you, we study the population through the sample we collect from it in this case. So this is the process of statistical study in general. Here we have some examples about descriptive and inferential statistics. The first one, the average age of the students in a statistic class is 22 years. Does this statement describe descriptive or inferential statistics? Give you 5 seconds to think about it. So as you can see here, It says what? The average age of the student in a statistic class is 22 years. So it's describes the average age in the class. So it's a descriptive statistics. Okay, here we cannot find any prediction, we cannot find any conclusions, we don't make a decision here, we just describe the average age of the students. Okay, so this is descriptive statistics. Okay, and the second question, from past figures, it's predicted that 30% of the registered voters will vote in the March primary. Does this statement describe descriptive or inferential statistics? Because we have here predicted this word, that means we are dealing with inferential statistics. Because if we return to inferential statistics, you will find that there are three um, words: predicted, making a decision, and conclusions. Three things, three words. Okay, so if you find these three words, that means you are dealing with inferential statistics. Okay, something else, of course, here it says that from past figures. From past figures, that means we used the past knowledge, the past numbers, and make predictions to the future. So this is also another way you can know if it's inferential statistics or not. Okay, last one. The average American viewers watches 151 hours of TV per month. Is it descriptive statistics or inferential statistics? It's inferential statistics. Why? Because, of course, this number, 151 hours of TV per month, cannot be calculated from all American adults. We will not ask all the American people in about that, right? So in most cases, this number came from a sample. And from the sample, we generalized this number to the entire population. So this is inferential statistics. It's not descriptive statistics. Okay, so here you have the answers. Another example, in a marketing campaign, 1,000 cola consumers are given a blend taste. It's a taste test in which two brand names are disguised. Each consumer is asking you to state a preference for brand A or brand B. Here we want to describe what is the population, what is the variable of interest, what is the sample, what is the inference. Okay, so the population here will be all cola consumers. This is the population, all cola consumers. What is the variable of interest? Is the preference of brand A or brand B. So the preferences. Okay. What is the sample? It's 1,000 cola consumers. This is the sample. The inference here will be about what? How we can know which brand the people preferred? By calculating what? The percentage of people who prefer brand A and the percentage of people prefer the brand B. So this will be the inference will be around the percentage of the preference in this case. Okay, so here you have the answers. The population is all cola consumers. The variable of interest is cola preference. The sample is 1,000 cola consumers, and the inference is percentage of cola consumers who preferred each brand. So our first part of this class, we will learn the descriptive statistics, okay? Which means we have here 4 elements of descriptive statistical problems: the population or sample of interest, one or more variables, characteristic of the population or sample units. We will, of course, deal with tables like frequency table, graphs like bar, pie chart, histogram, or numerical summarized tools like the averages, the mean, the median, the mode, the standard deviation, the variance, the range, okay? And then identification of patterns in the data, okay? So again, descriptive statistics uses tables, graphs, numerical summaries tools to represent the statistical result. The second part is about inferential statistics. We have 5 elements of inferential statistical problem: the population of interest, one or more variable that are to be investigated, the sample of the population units, the inference about the population based on the information contained in the sample, and then a measure of the reliability of the inference, okay? Which means here, the fifth point here means the estimation and the hypothesis testing. Of course, these are the last 2 chapters in this class. So inferential statistic is to draw some conclusions about the population using samples with some degree of uncertainty. This, of course, is the definition of the inferential statistics again. Okay. So using statistics software or calculators are very important in analyzing the data. Some examples for statistical software are Minitab, GMB, StatCrunch, SPSS, and R. These are popular statistical software in most of the universities and the college campuses. Okay. Also, for the calculators, we have TI-83, TI-84, TI-89, and the TI Inspire family calculators. These calculators also has some simple statistical and the graphs packages there, so you can use it also when you need to do a statistical analysis. In our class, I said to you, we will use Microsoft Excel. Of course, it's not a statistical software, but it can perform some statistical analysis. If you wanted to do some more advanced statistical analysis, you can add to Excel something called real statistics. It's as advanced software that can be added to Excel to perform more advanced statistical analysis. Okay. Of course, using the technology has a problem. The problem is what? That the computer will perform the statistical analysis you request, whether or not its use is valid for the given situation, because it's a machine, okay? And you fill this machine with numbers. So whatever give it a number, of course, he will calculate it and give you the results. But you have to fill this machine with the correct data so you can have the correct results in this case, okay? So so as you can see, you, not technology, must select valid analysis. You will select the valid analysis in this case, okay? Data files. Of course, we are in the digital era, which deals with a lot of data every day. So large sets of data are typically organized in what? In tables, or sometimes we call it spreadsheets, okay? Like what we have in Excel. So in this case, we call it data file. Each row contains measurements for a particular subject, and each column contains measurements for a particular characteristics, which means a variable. So and simply, each row is the cases, okay? And each column is the variable we are interested in. The data bases, these are an existing archive collection of data files. So this is it's not just one file, it's a collection of data files. Not all databases given reliable information. Before you give credence to such data, survey that the data are from the trustworthy sources. Okay, for example, you can find some data sets online, but you don't know if these data are trustworthy or not. Okay, so you have to make sure that you deal with a trustworthy worthy sources in this case. Something called web apps. What web apps? It's instead of installing a software or a statistical software on your the laptop or your computer, you can use web apps instead. So as you can see here, it's an application that runs in a browser like Chrome's, like Explorer, like Safari, okay, used for performing a specific task. Of course, it's useful for performing activities that illustrate the ideas of statistics. Create, of course, you can create a simulation with this computer using a computer to mimic. So, of course, a simulation means to mimic a situation will happen, okay, by electing a sample and use the statistics in real life. Okay, so we call it simulation, as you can see. Okay, so this was a very quick overview on the statistical definitions. Okay, and it's very, very important in this chapter to know what is the difference between descriptive statistics and inferential statistics, difference between parameter and statistic, difference between population and the sample. Okay, of course, the definition for the data, definition of the variable, okay, the definition of subjects, okay, definition for the statistic itself, and of course, the process of the statistical study. Thank you so much for watching this video, and see you in the next chapter.